Apparently, you can get super smooth prints by ironing them. Seems dangerous and messy, but okay. Stop! What do you think you're doing? We're talking about a slicer setting. Oh, that makes more sense. Phil here in the layer by layer, where I'm going to be talking about using ironing, the slicer setting, to get buttery smooth top layers on your prints. There are a few things to discuss. A, what is ironing? 2, what do all the different settings do and what are the best settings for different filaments? And lastly, why not just do this smoothing process all the time? We'll start by cutting to my super duper high-end graphics to see what the heck ironing actually is. As you know, 3D printing works by laying lines down next to each other that would look a bit like this in a cross-section. What ironing does is extrude a small amount of filament while working across the top surface at the same Z height. The hot end softens the top layer while extruding out a small amount of filament that fills in the gaps, leading to a smooth surface, if you get the settings right. Also, it'll be much smoother than this drawing. I'm not very good at drawing. To test ironing out, I modeled up 5 different test prints. One that compares different speed settings when paired with flow settings, and then 4 more that look at the other ironing settings, which we'll discuss later. The default setting for speed is 30 millimeters per second, and for flow it's 10%. With that info, I decided to use increments of 2 for flow and increments of 10 for speed in my speed and flow comparison model. Turns out the increments of 2 were a mistake, but we'll get to that learning later. I initially made a model in Blender and would normally show that process here, but it turns out BambuStudio does not like having too many modifiers, and it started pinwheeling endlessly. So I threw all that work away and started fresh and modeled up the same thing in BambuStudio so that I could change the settings on each cube individually without using any modifiers. I also labeled the axes for ease of use. The general idea here is that you use the first print of speed and flow to find what looks best, and then you can use those settings to print the other 4 test prints to see what impact, if any, those settings have. With the model done, I started printing the speed and flow test piece with BambuLab Basic PLA. The 40mm per second speed and 6% flow, and the 30mm per second speed with 14% flow showed some promise, but these weren't the buttery smooth prints I was hoping for. So at this point I went back to the drawing board to consider if maybe the increments were wrong. Or that's what I wish I could say, because I ended up printing not 1, not 2, but 3 different sets of the other test prints at different settings, which unsurprisingly ended up looking pretty meh. After that waste of time and filament, I thought that perhaps I should do increments of 5 for the flow rate. So I went back in and changed all the labels and settings. This was fairly time consuming, so while I do that, why don't you go ahead and give this video a like and consider subscribing. With the model updated, I printed it out and now things were looking smooth. With PLA it seemed I was spoiled for choice, with many excellent looking smooth tops. To narrow it down, I decided to use speed as a first tiebreaker and flow as a second tiebreaker if needed. So if 2 cubes looked just as good, I would go with the fastest speed setting, and if they were at the same speed, I would use the lowest flow to save filament. With all of that factored in, it looked like the best looking cube was the 50mm per second with 25% flow, so I printed out the secondary test prints with those settings. But we aren't quite ready to talk about those settings just yet, because I also went ahead and printed out a speed/flow test using PETG and ASA, which really showed how different the filaments can be. For the PETG, there were some settings that ended up tearing whole chunks out of the top, and frankly no setting was perfect. Even the best setting of 30mm per second speed and 35% flow had some inconsistent surfaces. Though I found the most interesting one to be the ASA, which ended up looking best at a very slow 20mm per second and only 5% flow, which really highlights how different the settings can be between filaments. With all that sorted, now we can finally get to discussing those other settings. I'll start with ironing type. There are 3 options here: top surfaces, topmost surface, and all solid layers. Top surfaces will work on any of the top flat surfaces of a model. If you have a set of steps modeled, the top of each step will be ironed. If you have it set to topmost surface, only the very top stair will be ironed. And for the all solid layer setting, this means even the solid infill layers will be ironed. In general, that setting should be avoided because it massively adds to the print time and doesn't generally lead to better prints. The next setting is the ironing pattern, and there are 2 options for this: rectilinear or concentric. This one really surprised me. I assumed rectilinear would be better for squares and concentric would be better for circles, which is why my test model has a circle and a square as options. But in all cases, rectilinear looked better. For a square surface, the concentric settings created triangles in each quarter of the square. And on the circle, it actually created a seam. I've been showing the PLA print, but this also held true for PETG and ASA. So in general, I would say you should stick with the default rectilinear setting. If somebody else knows of a time when concentric looks better, let me know in the comments. With the pattern sorted, it is onto the line spacing. The default setting for this is 0.15 millimeters, and it's recommended that this setting is always below the diameter of the nozzle, which for these tests was 0.4 millimeters, so that the ironing path will overlap. With that in mind, the smaller the spacing, the longer the ironing takes. It's a balance. For all the different filaments, the 0.15 setting ended up looking best, and at higher line spacings, it was pretty obvious it didn't look great. An interesting find with this was that for PETG, the 0.05 millimeter spacing actually had a cloudy portion at the bottom that didn't look very good, and ASA actually had gaps in the surface. So in this case, going for a lower line spacing added more time and ended up looking worse. Now that we're properly spaced out, we'll look at the ironing inset setting. This is a bit of a subtle one. It starts ironing a small distance away from the edge of the top surface. The inset is supposed to help with thinner things like letters, where an extra bit of filament could end up overhanging and actually make it look worse. So I made sure to include letters in the test print along with the standard square. I said earlier this was subtle, and that's really down to the fact that I didn't notice much of a difference at all at low values, all the way down to 0. For all filament types, this still looked smooth and crisp. Things did get noticeably worse at higher settings on the letters. I suspect that this is because it got large enough that it didn't iron it at all. Ultimately, I think you can leave this one at the default without worrying too much about it. And finally, there's ironing direction. The default for this is 45 degrees, which means it will go at a 45-degree angle to the direction of the layer being ironed. The option to change this only becomes available if you have develop mode turned on in BambuStudio settings. For all the different filament types, the 45-degree angle ended up looking best. Though for PLA it didn't make much of a difference at any angle. But in the case of PETG and ASA, other angles caused part of the top surface to be cloudy, as seen here. Ultimately, this probably isn't worth changing in most cases. We made it! That's all the settings done, and you're saying this is great. I'm going to iron everything. Ho now. I'm happy you're excited, but there are some downsides to consider. To start, the nozzle actually drags across the top surface while ironing. This can be bad for two reasons. The first is that it could lead to filament collecting on the nozzle and creating the potential for the blob of death. This can be mitigated somewhat by using Slice Engineering's plastic repellent on the nozzle, link in the description. The second issue with dragging across the top layer is that it can knock the piece right off the build plate, like a cat when it encounters, well, anything. There's also the time to consider. Ironing is not a fast process. I sliced a basic 25mm cube with no ironing settings, and on my P1S, the estimated print time was 12 minutes 3 seconds. When I turned on ironing with the default settings, that time jumped up to 14 minutes and 23 seconds. 2 minutes and 20 seconds isn't much, but that is approximately a 20% increase in print time. I did another test with a cube with a top surface of 200mm. Without ironing, it was going to take 3 hours and 56 minutes to complete. With ironing, it would take 6 hours and 24 minutes. That is approximately 70% longer. That is a huge amount of time, so you have to consider if it's worth it. Let's say you've determined it is worth the time. Well, the low flow rate for a prolonged period that comes with ironing can lead to another issue: heat creep. Heat is supposed to stay at the tip of the nozzle. With so little filament being pushed out though, the heat can creep up the nozzle and out of the melt zone, which can then lead to clogs and an overall bad day. Though fortunately I haven't run into this issue myself. And while those are big concerns, there are a few more things to consider. Using the wrong setting can literally lead to pieces of the top being torn off, which ruins the entire print, and wastes all that material and time. It's also important to note that ironing can mess with your Z height, so it isn't a good option for parts that need to be precise. After all that then, what conclusions can we come to? Well, given everything I just went over, I suppose that conclusion number 1 would be it isn't for every situation and trade-offs have to be considered. B, different filament types require different settings, and the default settings are likely not correct. Roman numeral 3, it might be best to not iron PETG. I thoroughly dried the filament I tested with, but there weren't any settings that I think looked really great, though your mileage may vary. Quattro, a link to this ironing test is available for you to use for free at the link in the description. And lastly, giving this video a like would be real smooth, and you might like to check out one of these videos next.